Greetings there, welcome to Edu-ca-te. Today we're going to be learning about generalizing a quadratic pattern formula. Okay, so a quadratic pattern formula is given by what? Tn is equal to an squared plus bn plus c. Okay, an squared plus bn plus c is the formula, the general rule used to find a quadratic pattern. Okay, so this can apply to each and every quadratic pattern you can find. Yeah, so it's a method of finding a quadratic pattern, or it's a formula that makes a quadratic pattern, so it does not change. That's just like a manual for inventing a certain car. It will always stay the same. Okay, so this is the formula. So how do we break down the formula? How do we see how can we use this formula to find the general rules of other patterns? So this is going to be pretty easy. So number one thing, there's this thing called generalizing. Generalizing, the rule is that the simple use of variables which can represent a certain number to find a simplified solution. So how can we do this? Okay, first of all, this n, as we said, it represents the term number or the independent variable. This n can change anytime. That is why whenever you see this pattern, these numbers can be anything else, but then this n will always be n. So n can change. Yeah, n can change. Okay, so here we can replace n with 1 squared plus b times n 1 plus c. So this is the use of variables. Variables are alphabets which can be used to represent a number. So it means if you are using a variable, you can use a in place of 2. You can use any variable. So here, when you multiply here, you get a plus b plus c. Okay, because a times 1 squared is 1, so a times 1 is a. B times 1, anything multiplied by 1 is itself, and then plus c. Okay, so in order to get to the next one, at least you must have at least four terms here. Okay, so here we can substitute with term 2 plus b multiplied by 2 plus c. Okay, so here this will represent the coefficient of the nth term here. So here we can say 2 squared is equals to 4. So here we can actually have 4a plus 2b plus c, because b multiplied by 2 is 2b. Okay, and then we can also use a third term, and we can say a multiplied by 3 squared plus b multiplied by 3 plus c. Okay, 3 squared is 9, so this is 9a plus 3b plus c. Okay, let's have the last term here, tn, a multiplied by 4 squared plus b multiplied by 4 plus c, whereby we will have 16a plus 4b plus c. So we are using this to be able to generalize. We are using this to be able to find a rule that can apply to find other rules. Okay, you understand? That's just a one. Okay, so if we were to do this, we have to say this is term 1, term 2, term 3, and term 4. Okay, we link them together like this. Okay, so at 1, where there is 1, we got this, right? A plus b plus c. Where there is 2, we got this, 4a plus 2b plus c. Where there is 3, we got here 9a plus 3b plus c. Where there is 4, we got this, 16a plus 4b plus c. Okay, number one thing to know is that if it's a quadratic, quad can mean this squared here, this squared. So if it is a quadratic pattern, it simply means that you have to have two differences. You cannot have only one. That becomes a linear pattern. So to be able to find the first difference here, you have to say c minus c is 0. Therefore, we won't write any c. Therefore, 4b minus 3b is equals to only 1b, and then 16a minus 9a will be equals to let's see, 16 minus 9 will give us 7a plus b, right? And then c minus c here will be 0. The c is cancelled. Once you have these like terms here, it's simple. C and c will cancel off, and then 3b minus 2b will remain with b, while 9 minus 4 will remain with 5a plus b here. Now we have 5a plus b, 7a plus b, and then we'll have here c minus c will be 0, 2b minus b will be b, and then 4a minus a will be what? 3a. So 3a plus b, 5a plus b, 7a plus b. This is our first difference. So since we know that this must be a quadratic equation, so we have to find the second difference. b minus b is what? 0. 7a minus 5a is 2a. And then b minus b is 0 again. You don't have to write the 0 because it's nothing. 5a minus 3a will be 2a again. So it means that this is the general. By meaning general, we just mean that it's something that can be applied to many various patterns. It means that it can be applied to thousands of patterns here. That is why most of the times we'll be equating 2a, 3a plus b, a plus b plus c. Okay, so this is how it works then. If I was to give an example and give this pattern 2, 5, 10, 17, and then 26. Okay, and then 26. Let's say, yeah, this is our first term, second term, third term, fourth term, fifth term. So let me just write this second difference. And now, to be able to conclude this, first of all, let's find the difference here. We did that in another previous video. 9, 7, 3. Therefore, these are not the same. We have to find the second difference. So to be able to find the equation, we equate this to this, any of these. Why do we equate to any of these? Is because these and this and this is the same thing. 2a and 2a is the same thing. So you can equate with this, or you can equate with this. So when you say general, we mean that this will stay constant in any pattern. Okay, and then this first term, you will link it up to this term, which is 3a plus b. That's why we say 2a is equal to 2, while 3a plus b is equals to what? To this 3. You see, and then a plus b plus c will be equals to what? To the first term of the sequence, this term here. So this is general. General means it can be applied to any form of pattern you will get, which is a quadratic pattern. So here, a plus b plus c in this term will be equals to 2. Therefore, it means you can basically solve this by dividing with 2 here. You get a is equals to 1. By multiplying with this one here, you get b is equals to 0. And here, by adding here, is equals to 2, you get c is equals to 1. So this is basically it. Tn is equals to an squared plus bn plus c. Okay, so here you substitute with 1, 0 plus c, whereby n squared, this is 1 here, plus 1 is your general rule. It's just a simple way of finding the general rule here. So here, you don't really need to do this every day because this stays constant. These 3, this one, and this one, they will always stay constant. The 2a, the 3a plus b, the a plus b plus c will always stay constant. So how do we conclude here? We'll conclude by saying that 2a is equals to the first term of the second difference. So it means this term here, the second difference, this very first term in any pattern will be equals to 2a since we generalized it there. And then it will mean that 3a plus b will be equals to what? To the first term of the first difference, because we generalized it here that 3a plus b will be equals to this term. Any term that is found first at the first difference will be equals to 3a plus b, and then we'll have a plus b plus c is equals to what? Is equals to first term of the sequence. So by first term of this sequence is this term here. So any number you will get here will be equals to a plus b plus c when you are finalizing or when you are getting the general formula to calculate whatever pattern that may be. So this is generalizing. We generalized here so that you can get the values that help us to get any pattern. So we just broke down this formula into these components, into these singular components, so that it can be a bit easier. So just make sure that you know that 2a is equals to the first term of the second difference, 3a plus b is equals to the first term of the first difference, a plus b plus c is always equals to the first term of the sequence. So if you are able to know that this and this are equated to this and this, then you will simply know each and every time when you have a first difference and the second difference and this sequence itself. So it is easier that way. Thank you for watching. Please don't forget to subscribe to this channel and to support us.